All right, I will get started. First of all, I'll briefly introduce myself first. Hi everyone, my name is Fiona and I'm the Content and Social Media Coordinator here at PXchange. Welcome to our webinar on predicting customer churn with the Machine Learning Solution Template. This is where we demonstrate how you can use our new Customer Churn Solution Template to start predicting customers who are at risk of churning. This way, you can implement the right retention strategy before it's too late. First of all, thank you for taking time out of your busy schedule to join us today. We promise you it will be worth your time. Let me first introduce our company to you. PXchange is a deep tech company that focuses on the mission of democratizing data science and AI to everyone. So if you're not a data scientist or machine learning expert, don't worry. Our flagship product, the AI Analytics Engine, is a no-code machine learning tool that makes it easy for anyone to develop machine learning models. For today's session, I am joined by one of our expert data scientists, Kathy, and she will take you through a step-by-step demonstration on how to use our Customer Churn Solution Template. We will start the webinar with some introduction, followed by the Customer Churn Prediction use case demonstration. And we will have a Q&A session at the end. So if you have any question for us at any point of the webinar, feel free to pop your questions in the Q&A box. Now, if you are wondering, what is the AI Analytics Engine? Well, the engine is a complete end-to-end machine learning tool that makes it easy and that takes you from preparation and analysis of data all the way to model deployment in minutes without any coding necessary. It streamlines the traditional end-to-end machine learning process and empowers anyone, even non-technical users from any industry, to create and deploy their own machine learning models. To make AI even more accessible to everyone, we've taken it easy to the next level by building machine learning solution templates. These templates are designed to help users create machine learning solutions from start to finish, generating results that can be used directly in your systems. For now, we have the Customer Churn Solution Template that's designed for non-contractual and monetary transactions. This refers to purchases that involve spending money and customers not informing the business whether they will stop purchasing at a date. Some examples are personal banking, e-commerce, retail, and wholesalers. This is perfect for marketers, growth, and customer success specialists. But stay tuned because we will be introducing templates for subscription-based churn in the near future, where industries such as telco and internet service providers will be able to predict when their customers will stop paying for their product or service. All right, before we jump in, we'd like to know all of you better, and we are going to take the next couple of minutes to ask you some questions. So I'd really appreciate it if you could participate by answering the poll questions. I have the first question, which is, which industry are you from? Right, looks like we've got a mix from everywhere, but a couple of you chose others. So I'll be really interested to know where you guys are from. In case any of you are unfamiliar with customer churn, it is actually the number of customers that stop using your company's product or service during a certain time frame. It's probably the single most important metric to get right when it comes to business. It indicates if your customers are getting value from your product or service, and is definitely the key driver of revenue. It is also one of the biggest challenges that many companies worldwide are facing. Why? This is because customer churn introduces not only loss in income, but also other negative effects on the operations of the companies. In many industries such as banking, customer churn prediction plays an important role in business success due to the fact that attracting new customers is 5 to 10 times more expensive than retaining existing ones. So from an efficiency standpoint, it's definitely worth it to make sure your customers stay. Moving on to the second question. What do you think is the average churn rate in global markets? The answer is actually 30%. And just for your reference, the average churn rate that is considered good is between 5 to 7%. although of course it varies across different industries. Now, if you're wondering, what can I do about customer churn? Well, let me tell you that customer churn is bound to happen, but it pays to do everything in your power to reduce it as much as possible. That's because it's not just a business problem, that's just a side effect. It's about understanding why a customer along the way somewhere is not happy. And that is definitely a problem worth solving. And if you can get it right, it's not just about the immediate revenue you stand to gain. It's the multiplier of delivering a better customer experience. That being said, customer churn prediction and prevention is and should be a crucial part of any business growth strategy. Imagine having the superpower to identify customers who are at risk of leaving, knowing why, and coming up with retention strategies before they switch to alternatives. How great would that be, right? Well, the engine's Customer Churn Prediction Template provides a complete machine learning solution for predicting customer churn before it happens. Now we have the last question. What do you think causes a customer to churn? And the answer is all of the above. Customer churn happens to all businesses, even the best ones, and there's no way to ever stop it completely. But utilizing a machine learning template solution for customer churn prediction opens up plenty of opportunities for many businesses and industries. Not only is it easy to use, it also provides a complete machine learning solution from start to finish so that users can get their predictions in a matter of minutes. PR Exchange wants to take democratizing AI to the next level so that anyone, including a marketer like myself, can easily build a machine learning model with this template. Although there is no single action that can be taken once churn has been identified, it can often be as simple as reaching out with targeted communication or an offer or discount of some kind. This way, you would have all the ingredients you need to proactively implement retention strategies, so you can keep your customers from jumping ship. All right, let's now get straight into the data set that we'll be using for today's demonstration. We will be using a publicly available real-life data set from DataWorld. It is a real anonymized data set from a check bank, and we will use their data set to predict the probability of their customer churn. For those of you who are just joining us, welcome to the webinar. We are just about to start the demonstration in a little bit. If you have any questions or if you have a specific use case you would like some help with, feel free to contact us or book a free demo with our team. We will also reserve a couple of minutes at the end for a Q&A session. So if you have any questions, we will be happy to answer them at the end of the demo. For now, I'll pass the time to you, Kathy.
Hello, everyone. Let me start by sharing my screen. As Fiona mentioned, today we'll be looking at churn prediction use case in the banking industry. Our goal is to build a dashboard such as this that a relationship manager at a bank, for example, can use to detect which customers are in danger of churning. For example, here they can filter customers based on probability of churn. They can see the transaction history for that customer and the customer details and the probability that they will churn. And if they want to take further action, they can see how making different offers would change the probability of churn for this individual, so they can decide which product to offer to them. So what do we need to build this dashboard using machine learning? Obviously, first we need our customers' historical transaction data. So the data set that I will be using today is a banking data set. Each row is a transaction made by a certain customer. We have their account ID and the transaction ID and so on. And we want to use this data set to build our machine learning model, which will predict which customers might churn in the future. To give you more details and get more into the context of churn, Obviously, churn is very dependent on your business. So how you want to define churn depends on different industries and different businesses. But here we are looking at transaction-based churn cases. What does that mean? That means that we are looking at the number of transactions or the amount of transactions that the customer makes, or in the case of, let's say, a retail business, the amount of purchases that they make or the number of purchases they make. And if there's a decline in their purchase or number of transactions, then we can consider that customer churned. For example, here for the banking example, one definition can be if a customer makes less than 2 transactions in a 14-day period, then we consider them churned. You can see customer A here is considered churn at this time because from this point forward, they didn't have more than 2 transactions in the 14-day period. But customer B has more than 2 transactions in every 14-day period, so they are not considered churn. But obviously, the template that we will be showing today can be applied to different businesses and different use cases. Like I said, for example, in terms of retail, e-commerce, you can use the purchases made. You can use the number of transactions or purchases or the amount and so on. So you can modify that definition based on your need. All right, so how do we generally build a machine learning model? The process on the AI analytics engine and the general process for building and deploying a machine learning model and using it in your business is that first you need to start with your data. So you import your data. If your data needs any sort of cleaning, transforming, or anything else, you can do that in the data wrangling portion. After that, you will define what you want to use as the input to the model and what the model is supposed to predict. So for example, in this churn use case, you might want to use some statistics on the customer's behavior as the input, and what we want to predict will be their churn status. Are they churned or not? And once we have done that, then we can go ahead and select the machine learning algorithm that we want to use as our model. And we support a wide range of CPU and GPU-based models that you can select. Finally, you can evaluate your models and deploy them to your business. All right, this is the generic flow on the engine, as I mentioned. And the good news is in the template, a vast portion of this is even more simplified and automated for you. So even if you use this generic flow on the engine, it's much easier than coding it and building it yourself. But with the template, that will be further simplified. So for the churn template, actually what you need is your data, and you need how you want to define the churn. So first you import your data, your transaction data, and if you have any additional data sets on your customers, like customer information and so on, you upload those. Then you define churn, you give your definition of churn, you define which contributing factors you want the engine to consider as the input to the model. The engine will automatically build the data preparation and data cleaning, data transformation process for you. It will automatically select the best inputs to the model, considering the statistics that you suggested and the ones that is extracted automatically. It will build the models and presents you with the evaluation results. And you can very quickly either make predictions or deploy your model into production. Okay, let's go ahead and jump in onto the engine. I'm going to start on my homepage here, and I'm going to create a new project. Let's call it Churn template banking and create. So as you can see on the engine, I have the option to build from scratch, which is that generic flow that I talked about, which we won't be using today. Today, we're going to be using the template, and it's the Customer Churn Prediction Template. So let's select that and create our project. And here first, we have to provide our transaction data. So you can either connect to a database or upload your file directly, which is what I'm going to do. This is my historical transactions. And the reason we need this data is obviously because to build the model, you need the customer's past behavior, so that if any changes in that behavior occurs, you can use that change, the model can use that change to predict churn. And as you can see in my data set, each row is a transaction. I have the transaction ID, account ID, the date of the transaction, transaction type, the amount, balance after transaction, and so on. So this looks correct. I'm going to click next. And here I can see the engine has automatically detected the data types in these columns. If I want to, I can change any of them, but they're all correct. So I'm just going to keep that to what has been automatically detected and create the data set. Okay, it's uploaded. And create. So my file has been uploaded here. Now what I need to do is do some column mapping. So the churn template needs these three columns in the data set to extract those customer behavior statistics from. The first one is the customer ID. This is the column that identifies each unique customer. And in this data set, it's the account ID. So I'll select that. Next is the transaction date. Let's select that. And finally, transaction amount. So obviously, for your use case, this could be like the purchase date, purchase amount, or whatever columns that you have that basically reflects this data in your data set. Let's save and continue. And now we can add our customer information data. This is optional. This will include demographic information on our customers. Let's update it. And we can see the preview. You can see I have the account ID here, the date of birth, district ID, their gender, employment status, and the type of account that they have. Okay, next, and let's create. What I need to do is select the customer ID in this data set. So because we already uploaded our transaction data, we need this column here to basically define the relationship between this customer information data set and the transaction data set. This is the column that will be used to join the two data sets. So we have to provide it. But if you don't have a client information, you don't want to provide this optional data set, you can skip it altogether. Okay, let's save. I've uploaded my data. Now it's time to define churn. Okay, what I want to do is, like I said, I want to consider a customer churned if their total number of transactions in 14 days is less than 2. But obviously, you can select total transaction amount or define it in any other way you want. And I want to make predictions for the next month. So I want to know what's the probability of the customers churning in the next month. So I will select 30 days here. And now I will be defining those contributing factors which are potential inputs to our model. So we have two types of contributing factors. The first ones are the primary factors, which were extracted from the transactions. The engine uses different time windows to extract these statistics on the transaction activity from the users. So because I selected to make predictions for the next 30 days, that time window has automatically been added, but I can add more if I want to. Let's add 60 days and add 90 days. All right, and I have my secondary factors, which are the columns that are in the customer info data set. If I want to deselect any of them, I can, but let's just keep all of them. Okay. And now we can build our model. What we need to do is select the models we want to build. I can either let the engine automatically train, let's see, the top 3 algorithms for me, or I can manually select them from the list of algorithms that are available. You can see we have different classifiers here, both GPU and CPU based. So if you want to select a specific algorithm here, you can. But you can also let the engine decide. And what the engine does, it uses AI and your data to predict how each of these algorithms will perform. And it will train the top 3 algorithms for you. Okay, I'll just let the engine decide. So let's start building. As you can see, my app is being built. I have one that's already ready. So let's have a look at that to save us some time. So this is ready. I have my input data here. You can see this data set has been prepared automatically by the engine to produce the data set that's machine learning ready and will be used as the input to the model. If you want to have a look at that data set, we can see there are these columns that were added by the engine. These are the statistics that were derived in those time windows. And if we want to have more details of how that was built, we can take a look here. This is the data wrangling recipe that has all the steps that the engine took to prepare our data. So we have the concept of data wrangling on the engine. You can build your own recipes, obviously. And once you have built one, you can apply it to any new batch of data that comes in. So that can save you some good amount of time. But here the engine did that for us automatically. And if I want to, I can actually go ahead and make predictions here. So if I'm happy with what the engine has done and I want to make predictions, I can do that. But let's just, before making predictions, look into more details at what we have here. So if you want to see the full flow that was automatically built by the engine, we have our input data sets. The data was prepared. The data was split into training and test portions. The models were trained and they were evaluated on the test portion, and we can take a look at the evaluations results. So if you want to see the evaluation results, they are here. You can see we have 3 models. The best performing one is the XGBoost classifier with the highest prediction quality, but we have the logistic regression classifier that has lower prediction quality, but faster prediction time. So if I want a fast, basically, I have a use case that needs a fast response time, I can use this one in production, but otherwise I can just go ahead and use the one with the highest prediction quality. If I want to see more details of the models, I can click here. I'm seeing the summary and the insights into the model. We have different data science and machine learning metrics here. So if you're a more advanced user, you can use these metrics to make your decision. We have different curves, ROC curve, precision recall curve, and the confusion matrix. So once again, you can use these to decide, is this model performing adequately and can you use it in production or not? If I want more details on the model, I can take a look at the feature importance. So this tells me for this model's decision-making process, how important each of those input columns are. So it looks like the most important column here is the number of credited transactions in the last 3 months. Then we have the number of transactions in the last 30 days and so on. So I can first use this to do a sanity check to know, based on my expertise, does this model's decision-making process make sense or not? And if it does, this can actually also give me insight into the customer's behavior. So this tells me that maybe a low number of credit transactions in the past month, in the past 3 months, is an early sign of churning. So you can use that information to make decisions. If you want more detailed explanations on the model's decision-making process, we can look at the prediction explanations. Here we have some samples from the data set, and I can click on each of them and see, for example, for this customer, there's a very high probability of churning. It's 90%. And I can see that the reason is that they had a total number of 4 transactions in the last 90 days, and that alone increased the churn probability by 30%, and so on. So I can look at how this 90% exactly breaks down between different input features. And once again, I use this to analyze customers' behaviors and also just to see how my model is making decisions. If I want to have like a deeper insight into how changing the inputs would affect the predicted result, I can use the what if tool here. So here you can manually input different values for your input columns, and you can predict the results, and then you can add the prediction to a comparison. So if you want to change a parameter to multiple values and compare to see how that change affects the output, you can do that and compare the predictions and so on. Okay, let's say I'm happy with this model. Let's go back to our app. And I want to go ahead and make predictions using this model. So I'm going to go ahead, click on Make Predictions. I can either make a one-off prediction. So this is where I want to upload some data to make predictions using the model, or I can schedule a periodic prediction, which is very useful for production. Let's first try making a one-off prediction. Continue. And what I can do is either I can import a new data set, or I can make predictions for the next 30 days for the data that I just uploaded. So let's just do that and run a prediction. And as you can see, here's a flow chart of how the prediction works. I have my input data sources. The data is transformed by the engine to fit the format that is suitable as the model's input. We will make our predictions using the model, and then the prediction output will be provided to us, which we can export. This one is still processing, but when it's ready, you can see I have another one that's ready. You can preview it. This is the churn probability that was assigned, for example, for this customer. So I can take a look at the prediction results. And if I want to use it, I can download it, or I can export it to another project on the engine. All right, so that's for the one-off prediction. And let's also take a look at the scheduled prediction. So if I want to schedule prediction, what I can do is I can first select my model, then I can connect to a database, which will contain my updated, let's say, transaction data and customer information regularly. And I can define how often I want to make predictions. So let's say we upload our customer database and our transaction database every week. We can say every week, connect to this database, read the updated data, and create predictions based on that data. And we can define where we want to put our prediction results, which can be another database, or we can export it to the engine. And the benefit of that is obviously when I do that, I can use it in a dashboard like this. So for this dashboard, I can set up a scheduled prediction schedule. Every week, my probabilities will automatically update it. And my team members, let's say, they can use this to filter out the customers with a high probability of churn. They can look at how making a next best offer, which is basically based on changing the product type for them. How changing the product type, which was an input to the model, would affect the churn probability. So I can see that, for example, for this customer, it looks like they're on product 2. But if I offer them product 3, they will have a much lower chance of churning, almost by 10%. So I can offer this to them. So this can be used to make decisions based on the probabilities predicted. Okay, that's it for the demo. If there are any questions, I would be happy to answer.
All right. So I see that we have one question from Deepa. So she asked, is the AI analytics engine, can it be installed in my computer? Is it an open source available for free?
So the engine is a platform on the web. It can be deployed to local servers. So if you have a local server, you can deploy it. We can deploy to that for production. If you want to try it, yes, we offer demos. So you can use the free demo to explore the engine and use it.
So we offer a 2 weeks free trial for users to try the engine first. And then if they're interested, they can proceed on subscribing to whichever plan that suits them the most. Hopefully that answers your question. So does anyone have other questions? It seems like there's no question, but if you do come up with any questions at any point of the time, feel free to just reach out to us and we'll get back to you as soon as we can. Yeah, thank you, Kathy, for taking us through the demo and of course for showing us how to use the customer churn template. Just a quick summary. Customer churn is really important, and accurately predicting who is likely and understanding why it's happening is the first step in creating a retention strategy. Our customer churn template allows you to do this in a few simple steps and in the most efficient way possible. Thank you very much for everyone for joining us today. We hope you've gotten something valuable out of this webinar and that you are ready to start your journey with machine learning. Let's continue this conversation on our Slack community channel. We're happy to answer any questions. So if you have a use case in mind, feel free to book a free demo with us. Like I said, if you're ready to try the engine, we have a 2 weeks free trial for you. You can find all these links in the chat box below. Thank you, everyone. Hope you have an amazing rest of the day.